Hello guys, so today I'll be solving this problem. This is two best non-overlapping events. Okay, so the problem states that we have been given a zero index 2D integer array of events where event definition is I have a start time, okay, I have an end time, and I have a value, okay, which is uh, some value that I will get if I attend that event. Okay, so this is my event, okay, and I have been given some n events. Okay, cool. Now, so yeah, now the problem states that I have to choose two non-overlapping events, okay, such that the sum of their values is maximized. Okay, now I just need to return, like, I need to basically I just need to select two events, okay, that doesn't overlap, okay, and their sum of their values is maximized. So that's the overall problem statement. Now there is a note here. Note that the start time and end time is inclusive. That is, you cannot attend two events where one start and other ends at the same time. More specifically, if you attend an event with ending time t, the next event must start at the start or after t+1. So it's basically saying that, let's say there is a event which has, um, let's say s1, e1, and let's say v1. Okay, and let's say there is another event which is again starting at e1, okay, some e2, and let's say some value v2. Okay, I cannot attend these two events because this event is starting at the same time when this event is ending, so it's not possible. If I am doing e1 plus, if there is an event which is like e1 plus 1 as its start time, okay, some e3, let's say, and b3. Okay, now I can attend this kind of event. Cool, so that's the problem statement. So I think it's a simple problem, but due to the constraint we have to apply smart logic so that we can overcome n square time complexity. Because when you first look at the problem, okay, the problem only states that you need to select two events. Okay, so the first thing that can come to your mind is, okay, there are only two events, I can do two nested for loops. Okay, I can iterate over each event. Okay, so if I write the pseudocode, something like it will be something like this, like for event in events. Okay, and I can add one more for loop, let's say event 1, event 2 in events. Okay, I can check whether they are overlapping. Okay, if e1 is let's say there is a function overlapping, okay, that takes these two events and returns me whether they are overlapping. So if they are overlapping, I can continue. Okay, otherwise what I can do is I can create my answer variable, and I can update my answer variable as max of ans and event 1 value plus event 2 value, which will be stored at the second index, right, as per the problem statement, right? Start time, end time, and value. So value is stored at the second index. So yeah, so I guess this is the first algorithm that will come to your mind. Okay, you can easily do it. But if you look at the time complexity here, okay, so this is basically a brute force algorithm, right? So if I have been given n number of events, so this is a n square time complexity algorithm. Okay, now as per the given constraint, so the events length can be 10 to the power 5. So this will reach out to 10 to the power 10, which is more than a billion number of operation. Space wise, it's pretty efficient because we are not using any space. But yeah, as per time complexity, you will get a happy TLE. So yep. So how to act smart? Okay, now if you think, okay, what you need to do. So for every event, let's call it some event I. Okay, if you are attending this event, then why should you attend this event? Okay, if you are, let's say if you are attending this event, okay, you should look for a event, okay, that has occurred in the past, okay, some past events, okay, so that whatever value you are getting for this ith event, okay, let's call it vi, and whatever maximum value you have gotten for attending a event, let's call it like vmax past. Okay, so if you know, like let's say you have attended some k past events, okay, and now currently you are at the ith event. Okay, now what you can think is, for this ith event, if I'm getting this vi value, what event in my past can add up to vi to give me a maximum value. Okay, so with that you will be able to tell what two events you can attend. So yeah, that's the core idea behind the solution. Okay, so for every event, if you can efficiently find, okay, what is the past event I should have attended, so that my current event plus the past event's value, okay, um, maximize of my vi, my current event, plus the past event value. Okay, if I can maximize this, then I can easily store this in my answer, and I can say, yep, this is my past event. Okay, now here the thing is, we can select at most two non-overlapping events. Okay, so there is a chance, like for this ith event, you are not getting any event which is not overlapping for this current event. Okay, then in that case, you can simply keep on like storing the values, okay, and comparing with your answer whether your current event value is higher than your answer. So yeah, so that's the overall idea. Okay, so now let's think how to do it efficiently. Okay, because I'm saying for my ith event I need to look at my past events, right? Now how can I look at my past event efficiently? So a brute force way will be like the way we did it here. Okay, so for my current event, I'll simply loop over all the events from my current index, like 0 to I minus 1, and then I can compare value which one is maximum. But do you think that's a optimal way? No, right? Because let's say for some I plus 1th event, okay, you will be again doing 0 to I iteration, okay, for your new I plus 1. Okay, so is there a way in which I can claim that I can maybe transform my events to a certain structure, so that in my current iteration, okay, I'll keep on getting non-overlapping segments, okay, and I can easily store my past maximum value that I have gotten. Okay, so here the idea is, let's call it like concept 1 here. Okay, so here the idea is, you can sort your events by start time. Okay, now if you sort your event by start time, okay, and also let's say you have another data structure that takes the whole copy of your events, and let's say it sorts your event by end time. Okay, then you can easily uh, like easily run your iteration in a single pass to get your answer, which is here. Okay, now how can you do that? Let's say I sort my events by start time. Okay, so I guess it will be better if I show you an example. So let's say I have event 1 3 4. Okay, and I have an event, let's say 2 to 5 maybe. Okay, and let's say I have 4 4 and 3. Okay, let's say this is my event list. Okay, now let's sort the event by start time. Okay, sort by start. Okay, so if I sort them by start, they will be exactly same, because 1 3 4. Okay, so 1 is lesser than 2. Okay, 2 is lesser than 4. Okay, so they will be sorted in this manner. Now let's sort them by end time. Okay, so here I see this guy has a lower end time. Okay, so 2 to 5 should come first. Okay, then I see 3 is the next higher value in end time, so it should be 1 3 4. Okay, and lastly it is like 1 4 and 3. Okay, So if I draw out this test case, okay, so this will be 1, 2, 3 and 4. So for my first event, it's starting from here, ending at here, okay, and then for my second event, it's starting at 2 and ending at 2, okay, and it has a value of 5. My first event has a value of 4, okay, and for my last event, it's starting at 4 and ending at 4, okay, so it's a value of 3. So here we can easily see that if we attend 5, like my second event and my last event, okay, that should be my answer, right? So my answer should be 5 plus 3, okay. So these two events I should select because these two are not overlapping, okay, and I can go for like the first event and the last event, but if you check their summation of values, that is 4 plus 3, that is 7, okay, but this is lesser than what I'm getting by choosing second and the last event, okay. Now let's see how we can use this sorting logic, okay. So the idea is I'll be iterating over all my events with respect to this, okay. So let's call it for event in let's say sorted events by start, okay. So for event in sorted event by start, so from that I can collect my start time, okay. So let's call it st. So this will be event of 0, okay, and I can collect my current value, okay. So this will be event of 2, okay. I don't need the end time here, okay. Why? Because when I'm iterating from like when I'm iterating an array which is sorted by the start timestamp, okay, so I'm saying that all my end timestamp, okay, they will be sorted for the same start timestamp, okay. So I'll just tell you like why I don't need, okay, because here for every event I'll simply look at my past, okay, and whatever maximum past value I have gotten, okay, I'll simply compare that value, or like I will simply add that value for my current value, okay. So in order to store the past maximum value, what I can do is I will store a track, okay. So I will say past max value, I'll initialize to 0, okay. Now I will run a second for loop, okay, where I will say while now I will iterate this array, okay. Now this array is sorted with respect to the end timestamp, okay, in an increasing fashion, okay. Both are sorted in an increasing fashion, but the first array is sorted by start timestamp and the end and the second array is sorted by the end timestamp, okay. So I am getting the ending first here, okay. Now what I will do is I will create one more pointer, let's call it end pointer. I will initialize to 0, okay. Now I'll say while my end pointer is less than, so it's a basically a boundary check. So while my end pointer is less than my event's length, okay. Now I will say if whatever event I am getting in my end timestamp sorted array, okay, if that is not overlapping with my current value, then that means that is a valid past event that I should consider when I am comparing the maximum past value for my current event, right? So what I will say is for my sorted, let's say sorted events, or let's call this kind of array like end times maybe, and let's call this array like start times, okay, because I'm sorting with respect to start time. Here I'm sorting with respect to end time, okay. So I'll just erase this guy, okay, and I'll say for event in start times, okay. Now I'll say and so here I will say while my end pointer has not reached the end, okay, and my current event in my end times, okay, which is end times of end pointer, okay, is strictly less than my start time. That means I can consider this event to compare the, or like to add the value for my current value. Okay, here I will store the update my past max value to maximum of whatever value this end time contains. Of value of 2, and I will say past max. Okay, and I will keep on updating. I will keep on updating this pointer so that I can iterate over my end times. Okay, now how this is helping me? Okay, now as I'm iterating over the events with respect to start times, okay, I'm also using another pointer to iterate over all the past events, okay, that has occurred for every start event. Okay, now with that I am having a tracker that can tell me for every past event what is the maximum value I am getting. Okay, which means for the next timestamp, okay, I can directly use the shifted values of my end timestamp sorted array to get the value or to update the past max value. Okay, so here at the end, okay, my past max value will be containing the maximum value that I can attain in my past. Okay, so after that I'll simply update my answer to max of ans compared with current value that I'm getting for my current event plus my past max value. Okay, and yeah, my answer will be storing the maximum value that I can attain by attending 2 events, okay, which are not overlapping. Now here in this test case, how it will appear is, so I'll just do this first. Okay, so at first, okay, let's use a different color and let's use maybe blue. Okay, so at first my start pointer will be here, okay, and my end pointer will be here. Okay, so here I will say for this event, okay, I'll collect the start and the value, and I will check whether I have any event in my past which is not overlapping with respect to my current event. Now for this guy there are no past event, okay, which means this value will not run. Okay, then my answer will simply store whatever current value I'm getting for my event. Okay, so my answer will be 4 here initially, okay, for this. Okay, then I will move my pointer to this guy. Okay, now for this guy I will again check. Okay, so my current value will be now 5. Okay, now I will check whether I have any event in the past for this current guy, okay, which are not overlapping. Okay, now if I check, my end pointer is pointing here, right? Now if I compare the yeah, so here I need to check the end timestamp. So basically if they are not overlapping, that means the event or the past event end timestamp, okay, it should be strictly lesser than my current event start time, right? So if my past event is something like this and my current event is something like this, okay, and this is my past. Okay, so if I'm getting let's say this is S1 E1 and this is S2 E2, okay, the only way they can be not overlapping is when E1 is strictly less than S2. So this is what I'm doing. Okay, but let's say if but let's say I have something like this condition. Okay, my current is here and my past is here. Okay, so S1 E1 and this is S2 E2. You can clearly see this is not satisfying this condition and this is a overlapping case. Okay, whereas this is a non-overlapping case. Okay, so yeah, that's why I have like I only need to check whether the end timestamp, okay, whether the current event in my end times, okay, its end timestamp is strictly lesser than my current timestamp. Okay, cool. Now let's get back to the logic. So here I'm at this stage. Okay, now here the start time, okay, here my start time, which is 2, okay, it is not strictly greater than the end timestamp of where my end pointer is pointing, because this is also 2. That means I have no past event where the events are not non-overlapping with my current event. That means I will simply update my answer to whatever value I'm getting here, 5 plus, since I have no past event, that means 0. Okay, now I'll compare these two value. Okay, so my answer is 4 currently, and I am getting a new value which is 5. Okay, so my answer will update to 5. Cool. Now my start pointer will be at here. Okay, now the start pointer is basically an underlying pointer by this for loop only. So yeah, now I'll be pointing to here. Now what I will see is, so I have my start pointer 4 here. Okay, now my end pointer is here. Now if I compare the end timestamp of this event and the start timestamp of this event, okay, my start timestamp is strictly greater than this end timestamp, which means this past value I can consider to update my past max value. Okay, so here my past max value will be updated to 5. Okay, then my end pointer will move here. Okay, so here I will again check whether the end timestamp of my current end times event, okay, is strictly lesser than the start timestamp of my current event. I can see this is 3, this is 4, so it is strictly lesser, right? Or the reverse also, like my start timestamp is strictly greater than the end timestamp. Now I will check. So I have I'm getting 4 as the value in my past. Okay, but my past max value is already storing a higher value, so even if I am getting 4, I will not update my past max value by 5. Okay, so this is how my max will help me. Okay, cool. Now finally my end timestamp will move to here. Okay, now I'll check. So these two are basically these exact events, right? Which means they will be overlapping and my while loop will break. Okay, now finally I will update my answer to whatever past max value I have gotten for this event, okay, which is 5, plus the current value that I am getting for my event, which is 3. Okay, so my answer will be updated to my past value that I have gotten, okay, 5, plus the current value that I am getting, which is 3. So finally my answer will become 8, and as we have discussed, my answer is 8. So yeah, so this is the algorithm. Let's run it for one more test case. Okay, let's say I have been given let's say I have been given, let's say 1 2 4 and 3 4 3. Okay, and let's say 2 3 1. Okay, now let's sort them by start. Oopsie, sort by start. Okay, so if I sort them by start, so 1 2 4 will come here, 2 3 1 will come here, and 3 4 3 will be at the last. Okay, and if I sort them by end, okay, so if I'm sorting by end, so this will be 1 and 2 4 will come first because this is the lowest ending timestamp. Now 3 is my second highest ending timestamp, and 3 4 3 will again come here. So yeah, both are there, both are equal. But yeah, now let's see. So if I draw out this case, so here I'm saying I have 1, I have 2, I have 3, and I have 4. Okay, so I have an event from 1 to 2, okay, which has a value of 4. Okay, then I have another event from 2 to 3, which has a value of 1. Okay, then I have another event from 3 to 4, which has a value of 3. Now just by visualizing, I can clearly see I should select my first event and my last event. Okay, because they are not overlapping, and if I sum up their value, I'll be getting 7 as my answer. Right, now if I'm selecting this guy, okay, which is this event 2. Now this is overlapping with both of these events, okay, which means I cannot pair any other event. Now if I'm only taking this event, now this event is only giving me a value of 1, which is lesser than what I can get by attending the first and the second event, okay. Cool. Now let's see how this algorithm can solve this test case also, okay. Cool. So initially my start pointer will be at here and my end pointer will be at here, okay. Now I need you guys to focus why I'm sorting by ending. When I'm sorting by ending, I'm ensuring whenever I'm doing this 2-pointer kind of stuff, okay, whatever event I'm currently attending in my end times, okay, those will be always before my current start time, okay. That's why I need this sort by end timestamp, okay. Cool. Now let's go through this. So I'll create my answer and my past max value, okay. Cool. So initially I do not have any event for this guy in the past, okay. This is the first event itself, so my while loop will not run, okay, at all, and my answer will be updated to whatever value I'm getting for this event itself. So my answer will be updated to 4, okay, and past max value will be 0 only because there are no past events, okay. Then my start time pointer will be at now here, okay. Now here if I see, I have 2 and 3, okay, as my start and end, okay. Now here if I see what if this event, okay, now this is the event in the past, but this guy is overlapping, right, as we saw here, these two are overlapping, okay, which means I cannot consider this past event to update my past max value, okay. So I need to consider whatever value I'm getting for this event solely, okay. So this event is giving me a value of 1, okay, but I have already gotten 4 as my value, which is lesser than what I'm getting by attending this event solely. So I'll skip this event, okay, and basically nothing will be updated by considering this event, okay. Then I'll shift my start pointer to here, okay. Now here I have my start timestamp as 3, okay. Now I'll compare the start timestamp with the end timestamp. Now I can see here my start timestamp is strictly greater than the end timestamp of my end times, okay. So I'll just write it here, this is end times, okay, and this is start times, okay. So I can consider this past event because this is non-overlapping with my current event, okay. So here I'm getting a value of 4, so now I can update my past max value to 4, okay. Now my end pointer will be at here. Now here I have 2 3 1. Now here the end timestamp is overlapping with my current event in my start times. That means I cannot use this event as my past time, okay. So basically this while loop condition will break. Now whatever past max I have gotten, okay, I'll simply add up that value with my current event value, which is 3 plus this 4, okay. Now it will be 7, okay. So my answer will be updated to 7, and clearly we have already stated like our answer will be 7. So yeah, that's the idea. So just sort your timestamp in two fashion: sort by start time, sort by end time, okay. Now iterate over your start time, okay. Now just consider the values, okay, and just check whether any event in the past you can consider, okay, to be like to get the maximum past value, okay. So yeah, I'll be first coding in Rust. So yep, I'll just use this pseudocode for reference. Cool. So first thing first, so I need to create 2 event arrays, okay. So I'll say let mut start times, I'll say events, okay. Now I need to clone this value, okay. Now I will so basically I'm creating a copy of whatever input I have been given. Now I will also create another array which is this end times, okay. Now I will sort both of them, okay. So I will sort my start times sort by with respect to the start timestamp. So I'll write a lambda a b and a compare with b of 0, and yeah, I need to compare a of 0 to b of 0. Okay, and for n timestamp I'll be comparing the n times, which is a of 1 with b of 1, and here I'll say n times. Cool. So now I have two arrays. Okay, so my sorted arrays are done. Now I'll create my answer variable. So let my answer equal to 0. Okay, now I'll be creating a pointer to update my n timestamp iteration. Okay, so let mut n pointer, so I'll be initializing it to 0, and I will create one more variable to store the maximum pass value that I can get. Okay, so pastMaxVal, I will also initialize it to 0. Now I'll iterate over all the events in my in my start times array. So for event in start times, okay, so I will collect the start time and the value. So start, I'll call it maybe cur start, yeah, cur start. I'll say event of 0, and I will store the value also. So event or I will say let cur value as event of 2. Okay, now I will check whether I have any event in the past which is not overlapping, and can I consider this value. Okay, so basically for our while my n pointer is less than n, and the current event in my n times, okay, its n time is strictly lesser than my current start, then I can consider this event. Okay, so n pointer plus plus, and yeah, I cannot do plus equal to, I need to do plus equal to instead of plus plus because Rust doesn't allow this postfix operation. So yeah, and before updating I'll simply update my pastMax value to I need to use std comp max I can use. Yeah, so I'll update my pastMax value to the maximum of pastMax value compared with whatever value my past event has, so which is n pointer of 2. Okay, now why this is a good approach, because once I stored the pastMax value, okay, I'm updating my pointer. That means whatever value I have already collected, I can use that pastMax value for other events. Okay, for other events I mean when I'm iterating over my next events in my start times. Okay, I don't need to iterate from start again. Okay, so yeah, that's the idea. Now after this I'll simply update my answer to answer of whatever current value I'm getting plus whatever highest highest value I have gotten in my past, or the maximum value I have gotten. Now finally I'll return the answer. So yeah, that's the whole code, I hope, and fingers crossed it should run. It didn't run because I haven't created variable for n. So n is my number of events I have, which is events of len. Cool. And voila, all test case pass. Now if I submit, and it got accepted. Cool. So that's the idea. Now if you look at the time complexity here, okay, so what I'm doing, okay, I'm cloning these two arrays. Okay, so whatever number of events I have, I'm doing it twice, so that's a big O of 2n. Okay, then I'm shorting those two arrays. Okay, which is like the number of events I have log of n. Okay, so this is like 2 times I'm doing, or I can say twice of big O of n log n. Okay, then I'm doing let's break it up cleanly, and then I will tell you the worst case. So there is a big O of n here, then there is a big O of n here for the copy, then I am doing n log n to update all the events in my start times with respect to the first start time. Then for end time also I'm doing a sorting. Okay, then I'm running this loop. Okay, now for every event in the start time, okay, I'm running this while loop. Now here the while loop, I'm not starting from the start itself, okay, or the start of this end times, okay. I'm starting from an offset, okay. But at max, I'll be touching every element in events twice, okay. One in start time and one in end times, okay. So this will be a big O of 2n, okay. This for loop and while loop mixture, okay. Because of this end pointer getting incremented at every event whenever this condition satisfies, okay. That means for the next start time, I'll be starting from a offset already, okay. I will not be again doing the n times iteration from the start, okay. And from that logic, I'll be touching every event in this events twice. That means I'll be doing a big O of 2n, right. Now here, all of them are like constant time operations, and yeah, finally I'm returning answer. So this is my time complexity, and what I can say is, at worst case, this n log n's will be will be overruling all this small complexities. So I can say big O of n log n is my overall time complexity, okay. Okay, cool. Now for space complexity, basically I'm creating these two copies of my events, okay. That means there is twice of space I'm using, like twice of big O of n, which is same as big O of n, okay. Cool. So yeah, this is the time and space complexity, and you can see like it's pretty efficient. Now I can show you the code in C++, okay. So the idea in C++ and the Rust are pretty similar, okay. So only syntax is different, but yeah, the idea is same actually. So yeah, here also I am so here in C++ I was having some issues by creating two of the start time and end times, okay. So what I did is, I considered this event itself as my start time, and I shorted it with respect to my start time, okay. So yeah, I was getting TLE when I was creating two copies of it, but by doing this, it got accepted. So yeah, so this is also a pretty efficient solution as compared to the Rust one, because here I need to create the start time and extra space of n events, okay. But here I'm using the input itself. So yeah, here also I'm doing the sorting with respect to start time and end time. I'm creating two arrays, okay. Now again, I'm iterating over all the start times, okay. And basically I can say iterating over start times, okay. Now with respect to every start time, I'm checking whether there is any past event which is not overlapping with my current event, and if it is, then just update my max value, okay. Then keep on updating, like iterating over your n times array until this condition satisfies, okay. And whenever this condition failed to satisfy, then simply take the past maximum value that you have gotten, add it up with the current value of your event, and update your answer. So yeah, this is the C++ logic also, like logic is same what we did in Rust. Now if I submit, and voila, it got accepted. Cool. Now finally I will show the code for Golang. Now in Golang also, it's pretty similar to what we did in C++ and Rust, okay. Only syntax is different, okay. So yeah, so similar to Rust, I guess. I'm using this clone method to create copies of my events, okay. Now if I don't create a copy of it, so what I will, so if I simply write let's say events here, okay. So I'll get a reference of this events, okay. That means whatever I'm shorting by start time, okay, those will be overridden by my end times, okay. So I need to explicitly call slices.clone to create copies of it. So yeah, that's the idea. Then yeah, the after that the concept is same, okay. Just iterate over every event in your start times, and for every event in start time, just look in the past whether you have gotten an event which is not overlapping your current event, and if it is not overlapping, then update your past maximum value. Now after all those past event iteration, if the loop completes, okay, simply update your answer with the past maximum value that you have gotten, added with the current value that you have gotten for your current event. So yeah, that's the idea. Now if I submit this, and this also got accepted. So yeah, that's the idea, and that's all. Cool. So I hope you learned something new. Okay. So if you like the solution and the explanation, please do subscribe to the channel, and you can like the video if you want. And please do comment so that I can know like where I'm lacking in my explanation. How can I better myself? So yeah, just stay tuned to watch more video tutorials on LeetCode Daily. So yeah, bye bye.